but smaller in size. Because imagine. متخيلة؟
You may keep this now. You
وبعدين
may keep it until you get the other one.
يعني تخيلي if
You may keep it until you get the other one.
أخبر شو فوق أنا أحس.
انت تحسي
أيوة. وأنا لابسة كعب.
قادرة تسوي ذيك الحركة. لا لا هو بيثقيل. خذي شوي
شوف
شوي.
تثقيل لأنه أنا حريقة.
دوسي هنا يستوي ليش؟ سدش يعني.
رجولي ما صغيرة.
يا أخي فشل بيبين إنش رجعتينا. رجعيه عادي ركبي فوقه.
خلي هو بس يوقف القصر ما يحتاج. خرج مع حلو هذا.
يمكن هو طالب.
ما هو طالب احنا جايبين.
الزين أمس. لا لا صح أمس كان يبين وجهه.
أيوة لو هذيك كانوا حاطين هذيك وجايبين هذا ممكن. بس لأنه هذا قصير هذا شوي كيف يطلع. صبر.
إيش هذا إيش؟
بودك. تعالي. شوفي ها. give me feedback.
إيش؟
شو
عادي تكلمي. قولي
1 2 3 لازم اتقدم.
ها؟
لازم اتقدم.
خلي عادي.
بس إذا الحين هذا كذا مناسب ولا؟
أيوة
أحسه واجد عالي.
ما في ما عندهم إلا هذه.
ايوه شوفوا وضعك كيف. مستراحة مو عالي لا.
أنت الحين من دونه كيف تحسي؟
وأحسن بواجد شوفي ها. من دونه.
لكن أنا البعيد ما يشوفوك إيش؟
يشوفوا. شوفي.
حطي ورا. الحين هو كلمته متى؟ لأنه ما حلو نحط ونطلع. في حد ثاني بيتكلم من بعد غيره بيتكلم. أحمد هذا صح؟
طلال. تخيلي دكتور طلال على هذا.
ليش؟
هو الكينوت سبيكر.
ليش الأمس اللي يقول؟
لا دكتور طلال اللي بيقدم السيشن كينوت سيشن. زين نادي هو خليه يشوف يناسبه ولا لا بعد.
ما بيناسبه. هذا نحطه لكن ما حلو إن نحطه مع دكتور عادل. قلت لأنه قصير. أنتوا حطوها
أو
شوية.
حتى هو ترى أبدا ما يبان.
أيوة هو أقصر. إيش؟
19 طالع.
أنا دكتور من؟ أنت؟ دانا؟ خليها هي توقف أشوف.
لا ما ماشي مشكلة كلمت. لا ما
بسم الله الرحمن الرحيم، والصلاة والسلام على من أرسل رحمة للعالمين، محمد خير البرية أجمعين. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Fatma Sayegh from National University, and I'm the host for today's First International Conference on Advanced Technology 2024. Ladies and gentlemen, as we are about to commence proceedings, please switch off your mobile phones. In the unlikely event of an emergency evacuation, all guests are requested to assemble at the assembly point. The safety staff will guide you on duty. Now please raise for the national anthem. Please be seated. The Honorable Chief Guest and Patron of the conference, His Excellency Dr. Ali bin Amr al-Shaydani, Under Secretary for Communications and Information Technology, Ministry of Transport, Communication and Information Technology. Dr. P. Muhammad Ali, Pro-Chancellor and Chairman of Board of Directors. Members of Board of Directors and Board of Trustees. Honorable Vice Chancellor Dr. Ali Al-Bimani and member of NU executives, distinguished guests and sponsor, staff and students, ladies and gentlemen, good morning. It gives me great honor and pleasure to welcome you all to this inaugural function of the First International Conference on Advanced Technology 2024, with a focus on application of artificial intelligence and cyber solutions for sustainability in engineering and healthcare. We believe that university research activities are of vital importance in imparting dynamism to the education process, and we take pride in being an institution that's open to new ideas and innovation and thinking, and shares new knowledge through a closer relationship with government, community, and industries, as well as educational and research institutions worldwide. In an era of modern technology, artificial intelligence, machine learning, deep learning, etc., offers immense opportunities to drive innovation, improve quality of life, and address some of the world's most pressing challenges. On the other hand, it also presents a plethora of challenges across various domains. We are sure that this conference plays a crucial role in fostering collaboration, advancing knowledge, addressing some of the challenges, and shaping the future direction of artificial intelligence research and applications. For the next 2 days, this conference will feature 11 keynote speeches and 82 technical presentations. We will commence the proceedings with a recitation from Holy Quran. let us have the privilege of seeing an introduction to our visionary leader, Dr. Ali Al-Bimani, our Vice Chancellor.
The extreme privilege of introducing Dr. Ali Al-Bimani, our Vice Chancellor and a notable researcher with numerous scientific publications. He is well known globally for his outstanding leadership in the higher education sector and his innovative contributions to promoting excellence in education and research. He was previously the 5th Vice Chancellor of Sultan Qaboos University from 12th February 2008 to 2nd July 2020. After his bachelor's degree in petroleum engineering from the University of Texas, Austin, he served as a petroleum engineer at PDO Oman from 1980 to 1985. Subsequently, he moved to Sultan Qaboos University as a faculty and pursued PhD at the University of Southern California. He was a member of many internal and external academic and planning committees in which he participated in important decision-making roles. Dr. Al-Bimani has made many academic and research contributions relevant to higher education by serving in many organizations and councils such as Oman Council for Education, the Research Council, Oman Medical Specialty Board, Board of Trustees for Colleges of Applied Sciences, Board of Trustees for Sharia College. Dr. Ali was instrumental in elevating the National University of Science and Technology as a premier university in the region known for excellence in education and research, as exemplified by the considerable boost in many international rankings, awards, and accolades. Ladies and gentlemen, please join hands to welcome the visionary academic leader, Dr. Ali Al-Bimani, who will deliver the welcome address.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وأصحابه أجمعين. Your Excellency Dr. Ali bin Amr al-Shaydani, Your Excellencies Dr. P. Muhammad Ali, honored guests, respected colleagues and attendees, students, Bismillahir Rahmanir Rahim. Today we are inaugurating the first international conference on the Advanced Technology, Icat 2024, at the National University of Science and Technology. We are privileged to have His Excellency Dr. Ali Al-Shaydani, the Undersecretary of Communication and Information Technology, with us, emphasizing the importance of collaboration among academia, industry, government, and private sectors to drive technology innovation, or technological innovation. Ladies and gentlemen, we are pleased to extend our warmest welcome to our chief guest, Dr. Ali Al-Shaydani. We are also joined by distinguished assembly of experts, academics, and visionaries from across the globe, all committed to the advance of technology and innovation. Over the next 2 days, we will explore into pioneering research, participate in enriching discussions, and establish significant connections that will influence the technological landscape of the future. I warmly welcome you all to this exciting endeavor under the theme of Application of AI and Cyber Solutions for Sustainable in Engineering and Healthcare, which highlights our dedication to tackling essential challenges in these crucial fields. Artificial intelligence and cyber solutions have demonstrated their transformative power, revolutionized industries, and impact societies worldwide, especially in fields such as engineering and healthcare. AI's ability to analyze vast amounts of data and produce valuable insights holds immense promise. In engineering, AI is propelling advances in designing optimization, predictive maintenance, autonomous operations, enhancing everything from supply chain to manufacturing efficiency, and contributing to sustainable urban development. In healthcare, AI is transforming diagnostic, personalizing treatments, and improving patient care management with algorithms that assist in early detection and continuous patient support through an enhanced system. However, these advancements also bring substantial challenges such as ethical issues, data privacy, and potential bias within AI algorithms. It's crucial that we tackle these issues head-on to ensure the responsible use of technology. We are proud to say Icat 2024 features a distinguished lineup of keynote speakers, experts in their fields, who will provide invaluable insights and foster discussions that inspire innovations solutions. We owe a great deal of gratitude to our sponsors and partners who support this crucial in bringing this event of fruitfulness, and our publications partners who will help disseminate the valuable knowledge shared here. Also, thanks to the conference organizing committees who for outstanding performance. Remember, together we can drive societal progress and shape a better future. Thank you all for participating and contribution in Icat 2024. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Dr. Ali Al-Bimani. The National University is a manifestation of our quest for social progress in Sultanate of Oman, and inherited from legacy of professional colleges in Oman. We recognize the importance of research and innovation in imparting dynamism to the education process. Let us see a short presentation on research at National University.
As the saying goes, necessity is the mother of all invention. Inventions have played a significant role in advancing life, teaching future generations, driving the economy and the world forward. In-depth research has played a pivotal role, right from fostering professional excellence to imparting quality education to students. The Sultanate of Oman has played a significant role in bettering the world through empowering research,
ويسهل مهامهم في إجراء أبحاثهم المتطورة.
The National University of Science and Technology aspires to promote and implement both discipline-specific and multidisciplinary research. Over the years, the university has achieved success in research with more than 100 funded research projects worth $3 million and over 3,700 publications. The National University of Science and Technology offers a unique blend of technological and management expertise when it comes to research. Some of the research areas that the National University focuses on includes energy and industry, information and communication technology, health and social services, and biological and environmental sciences. The National University of Science and Technology has classified its research discipline and facilities into 4 campuses: College of Engineering, College of Pharmacy, the College of Medicine and Health Sciences, and the International Maritime College, Oman. Under the exemplary deanship of Graduate Studies and Research, a conducive and appropriate environment was created to enhance the efficiency and effectiveness of the university's research programs and scholarly activities. With such constructive efforts, each of these campuses contributed significantly towards furthering newer technological and medical advances.
At the National University of Science and Technology, we recognize the importance of research and innovation for imparting high-quality education. The Deanship of Graduate Studies and Research ensures an intellectual and stimulus environment for advanced study and support of faculty and students to undertake cutting-edge research.
Let's explore the 4 campuses. The College of Engineering Research expertise include system reliability, availability and maintainability, intelligent maintenance monitoring and instrumentation, sustainable energy conversion technologies and management, novel materials and nanotechnology for the circular economy, artificial intelligence and machine learning, automation, robotics and manufacturing, innovative sustainable materials and structures.
I can proudly say the research activities at the College of Engineering has been contributing to the industrial development in many different ways, especially in resolving industrial-related issues and producing unique type of projects.
With a state-of-the-art Centre of Excellence in Environmental Science and Technology at the College of Engineering campus, the research in the area of desalination, water, waste treatment, renewable and solar water research is well on track.
In wastewater treatment, failing of membrane is a serious problem that leads to economical losses. To address this problem, we are fabricating a membrane with copper oxide, graphene and polyether sulfone. These two, along with the polymer polyether sulfone, and we are expecting to get a membrane with high strength and anti-fouling properties. This research is expected to give new directions as no similar researches have been made in Oman.
The College of Pharmacy has consistently worked closely with hospitals, health organizations and medical institutions.
The faculty of College of Pharmacy having a lot of research projects jointly with other institutions both in Oman and internationally, and these institutions include hospitals, universities and pharmaceutical industry.
They are constantly looking to offer the best possible advantage to their students, stakeholders and the community at large through its in-depth research domains. Their research expertise include the development of drug delivery systems, drug discovery and development.
We have 2 active research groups at the College of Pharmacy. We are also testing our drugs in the clinical settings. Along with the hospitals, we are doing some collaborative projects.
The College of Medicine and Health Sciences primarily focuses on bettering the lives of the community and people by partnering with hospitals and other research collaborations and researching in non-communicable diseases, public health and epidemiology, epigenetics, medical education and mental health.
During the last 5 years, the research at the College of Medicine and Sciences has come a long way to encompass research in clinical and biomedical sciences. The university has provided well-established research lab facility
And the Medical Research Center is currently being renovated as we speak. With the state-of-the-art facilities at the Medical Research Center at the College of Medicine and Health Sciences, the research covering areas of molecular biology, biochemistry, cell culture, immunohistochemistry, and immunology are being carried out effectively.
At our college, we have 5 very active co-research groups in which 2 different research types are used. The lab-based research, where research projects are conducted in collaboration with SKU or with Misra University. And the purpose of all these co-research groups is to improve the life quality of patients and maintain good health.
With a proven track record of successfully executing scientific and applied research projects for various industries, government bodies and the community over the past few years, the National University of Science and Technology is a name to be reckoned with when it comes to research and innovation. The National University of Science and Technology has helped foster individual research aspirations through its research and scholarly activities programs. This is especially evident in the way the National University has supported students currently partaking in research at the National University to alumni and faculty from the National University of Science and Technology.
I did 3 researches which helped me a lot in my middle school, and they increased the medical knowledge and experience in clinical knowledge as well. They already published and are planning to continue in this field of conducting medical researches, as they will help me now in this year for final year in middle school and the future, in my future career.
The International Maritime College Oman is focusing on research in the area of engineering, maritime and logistics management. Echoing the Oman Vision 2040, the National University of Science and Technology has emerged as a visionary research and innovation driving force, leading the change in the world today.
We are highly honored to introduce our chief guest and patron of this conference, His Excellency Dr. Ali bin Amr al-Shaydani, and the Secretary for Communication and Information Technology at Ministry of Transport, Communications and Information Technology, with a brief presentation.
I have the great privilege of introducing our chief guest and patron of this conference, His Excellency Dr. Ali bin Amr al-Shaydani, Undersecretary for Communications and Information Technology at the Ministry of Transport, Communications and Information Technology. He received his PhD in Electrical and Computer Engineering from the University of British Columbia, Canada, and obtained his master's degree in IT from QUT, Australia. He started his career as a faculty in the Department of Electrical and Computer Engineering at Sultan Qaboos University, and also worked as a visiting researcher at City University, London. He served as the director of the Research Centres Department, acting director of the Institute of Advanced Technology Integration, IATI, and Communications and Information Sector Director at the Research Council of Oman from November 2014 to January 2019. Before he was appointed as the Undersecretary in August 2020, he had been the Vice President of the Technology Support Unit at ASIAT Group since 2019. Dr. Ali al-Shaydani has published several scientific papers in peer-reviewed journals and international conferences. He has contributed to the launch of many initiatives in Oman, notably the Graduation Startup Program, the Smart Cities Platform, the Icat program, and the National Technology Transfer Network, NTTN, in Oman. We are highly grateful to His Excellency for gracing this inaugural function of Icat.
We are highly indebted to you, Your Excellency, for gracing this inaugural event, and thank you for the precious time and support extended to National University. On behalf of Icat 2024, I wanted to express our sincerest gratitude to the conference sponsors for their generous support. Your commitment and contribution played a pivotal role in making this event a resounding success. May I invite Dr. Talal Al-Belushi, the Head of Institutional Relation and Marketing Office and a member of Icat 2024, to moderate the first keynote session and conduct the proceedings.
Very well. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, distinguished guests, esteemed colleagues, it is my absolute pleasure to welcome you to the Icat 2024 conference. It's featured with 11 keynote speeches, and those keynote speeches will play a vital role in this conference by setting the stage, providing their expertise and inspiration, fostering connections, and creating a memorable experience for all of us. I want to extend my heartfelt gratitude to our esteemed keynote speakers for graciously accepting our invitation to join us today. Their dedication and excellence and their commitment to sharing knowledge makes them an invaluable asset to our conference. Ladies and gentlemen, our first keynote speech is on an important topic: monitoring machine learning models, building guardrails around AI, presented by a distinguished personality, Dr. K. Muhyiddin. Let us go through his brief profile.
Introducing Dr. K. Muhyiddin, a visionary leader in the realm of artificial intelligence and technology innovation. Dr. Muhyiddin's illustrious career began with a solid educational foundation, earning a Bachelor of Engineering in Electronics and Communication from NIT Trichy, followed by a Master of Science in Electrical Engineering and a PhD in Electrical and Computer Engineering from Stanford University. Dr. Muhyiddin's journey is marked by remarkable achievements and pioneering contributions in the field of machine learning and computer vision. As the Chief Technology Officer and co-founder of Score Data Corporation USA, he has spearheaded groundbreaking initiatives that have reshaped industries and transformed the way we harness AI. His illustrious career includes serving as the Associate Director at IBM Almaden Research Center USA, where he managed the operations of a major international research center comprising 1,000 scientists. Dr. Muhyiddin's expertise spans across diverse domains, from developing automated forms processing systems to computer vision-based mail sorting system that revolutionized the U.S. Postal Service, now deployed across all major mail sorting centers. His leadership earned him an IEEE Fellowship in 1999, the Computer World Horizon Award in 2005, and an Emmy Awards for Engineering in 2011 for innovations in storage systems. More recently, as CTO and co-founder of Score Data Corp., he developed AI/ML model monitoring systems and received the Open Innovation Award from NTT Data in 2019. Today, he continues to shape the future of AI and ML as a consultant, sharing his expertise globally. Please join me in extending a warm welcome to Dr. K. Muhyiddin, a distinguished figure in the world of artificial intelligence.
Bismillahir Rahmanir Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Oh, I say okay. Oh, it's okay. I'm okay. Good morning. The topic of my talk is model monitoring of machine learning models. And by guardrails, I mean protective mechanisms to prevent AI getting out of control. Now, I understand that the main theme of this conference is applications of AI to engineering and cyber solutions to engineering and medicine. What I'm going to describe applies to all areas of engineering, healthcare, finance, insurance, and so on, and all machine learning models, including neural networks, gradient basis models, and random forests, and so on. So we'll get right into it. So what is the problem? The problem is when machine learning models are developed in the laboratory by a data scientist, they may perform very well. But when it's deployed in the field, they don't work as well. In fact, this caused a lot of disillusionment among the early adopters in the United States when machine learning was at first adopted. The reason is the data change, the environment changes, and the models drift. For all these reasons, you need to continuously monitor machine learning models and update them if you notice it has drifted sufficiently from what it was originally designed for. Now the problem, the one way would be you have a prediction for an outcome. You wait until that event happens, compare the two, and if they agree, then you have a right prediction, and if they don't, then you have a wrong prediction. But the problem is you have to wait for, the prediction may be 3 months out or 6 months out, and the damage is already done. Suppose it's not correct. It might result in a big business loss. So the challenge is to detect it predictively. At the time you build the model and you deploy, as you get more new data in, you need to be able to tell, is the model behaving as it was originally designed? And if it's not, then you have to rebuild it with a more recent window of data. So this is also called, it's predictive monitoring, and we'll get to that. So the impact is to avoid losses to businesses from prediction errors. Why is it not? Oh.
You jumped one page.
Yes.
Yes.
Okay. I just wanted to give you a couple of examples of how data varies. This shows the average annual miles driven in the United States every year. So you can see there's a definite positive trend. This is in millions of miles. So 80 billion miles driven in early 1970s. And there's a definite positive trend upwards. But within each year, there is variation. That's because during summer, people drive a lot more, and winter, not as much. So your machine learning model needs to be careful and take that into account when you make predictions. Now, you see at the very end, there's a significant drop. Can you guess what caused that? COVID, exactly. People started working from home. They stopped going to work. And as a result, the number of miles driven significantly dropped. Another example, number of homes available nationally in the US. It's also going down, and it's a rapid drop in 2021 because builders were not building because of COVID. And this is also a function of mortgage rates. There are various functions that affect the number of, because the builders if they don't build, they're not homes for sale, and people don't sell when the market is not high. So for all these reasons, the data keep changing. Now I'm going to give you a real-world example where the outcome was disastrous for a company. There was a company called Zillow. Many of you would be aware of it. It's an online real estate company that you can find the value of your home. You go and put in your address. I think it's only available in the United States and Canada, not outside. But it'll show you the history, when it was built, when was it sold, how many times it was sold, and so on. And the main revenue comes from advertisements by real estate agents and mortgage companies. But they also had a business called Offers. And what they do is they buy homes, improve it, and then sell it back. So the typical turnaround time is about 3 months. They plan to do this within 3 months. Now, they need to know what the price would be 3 months hence, because they need to list early enough so there are enough buyers who might come forward. The problem was they were not monitoring their models. So during COVID, what happened was the labor cost went up, material cost went up, the supply chain became much longer. For all of these reasons, they underpriced their homes. They didn't update their models, and as a result, their prices were too low for the market. They ended up losing $422 million in 1 quarter alone. And the whole company, even though they had other revenue streams, ended up running a loss. As a result, they completely shut down that business and laid off 25% of their workforce. Now, if they had been monitoring it, they could have avoided that disaster. So it's a good lesson for all companies. Okay, now, in this talk, much of the world's business-critical data are in databases or in spreadsheets. So what I'm going to talk about primarily apply to them, but I know there's a lot of interest now in ChatGPT and generative AI and so on, and also touch upon monitoring generative AI models. So in the case of, when you predict an outcome, is it going to be yes or no? Or when you have a numerical projection, you can measure the accuracy of that prediction. However, suppose you give ChatGPT an essay and ask it to give a summary. There is no one correct answer. There are multiple sides to evaluating it. For example, was it brief enough? Was it fair? Was it a fair reflection of what's in the essay? Was it robust? In other words, even if you change the essay a little bit, would the summary be the same? Was it toxic? So, in fact, there's a Stanford holistic language evaluation model, HELM. It's a top-down approach for evaluating large language models. And the metrics they evaluate are accuracy, robustness, calibration, fairness, bias, toxicity, and efficiency. These are the metrics, not just accuracy alone. Because another one would be, suppose you ask the opinion of ChatGPT on a particular topic. It's very subjective evaluating it. So you evaluate it along these metrics. So I won't go into the details of that. That's for another time. So I apologize for the mathematical equations on this chart. I promise you this is the only page which has mathematical equations. And I give plenty of examples to clarify the method. So when, excuse me, may I for some water? When you train a machine learning, thank you. No, thank you. When you train a machine learning model, what you're really doing is to make the joint probability of the training data approximately equal to the joint probability of the training data and the predicted outcome. So let's say X sub t is the training data. It's usually a matrix, with each column of the matrix being a variable that's used in the machine learning model. And Y sub t is usually a vector corresponding to each row, what the outcome is, a value. Now, P sub theta are the parameters of the model, and X sub t is, again, as I said, the training data, and Y tilde t is the predicted outcome. So, you may be doing gradient descent and minimizing a loss function, etc., but at the end of the day, what you're really doing is making the joint probabilities approximately equal. Now, once it's deployed, you get new data. Let's call it X sub f for field data or future data. And Y sub f is the corresponding actual outcome. Now, we don't have that yet when we are doing the prediction. But the P sub theta, X sub t, Y t, which we earlier computed, will no longer be equal to the new joint probability. That is the basic problem. And using a Bayes theorem, we can write joint probability of the input data times the conditional probability. And the inequality may come, do you have a pointer? From either?
The remote control has a pointer. You can use the top button. Yeah.
Yeah, either the data probabilities are not equal or the model probabilities are not equal. When the data probabilities are not equal, we say a data drift has happened. If the model probabilities are not equal, we say a model drift has happened. But many of the time, they both happen. So you have both data drift and model drift. And if the drifts are, now we can calculate what the drift is, and if the drift is more than a certain threshold, and we have to establish a threshold with technique for establishing a threshold, then we say drift has happened, an alarm is raised, and the model has to be rebuilt. So the key to effective machine learning model is production, continuously monitor data and predict the distribution for drifts, and to correct the models when necessary.
Doctor, we have 3 minutes and 2 seconds, please.
Excuse me, I started at 9:45.
Yeah. So another 5 minutes.
I'm not even 1/3 of into the presentation.
It's about 50 minutes, so please.
Okay. So some people say, oh, so why do you bother having to compute probability distribution and so on? Statisticians will say, why not just look at mean and variance and so on of the distribution? And I'm just giving an example that's why that's not enough. On the left, you have a distribution which is a mean of 0. Both of them have mean of 0. They have a mean of variance of 5. But they have completely different distributions. And computing, comparing the mean and variance and so on won't work. You have to actually compute the probability distribution and find the distance metric. So another example on the right, we won't go into the details. So data drift can be detected by comparing the distributions of input data and comparing it with the base value, that is the threshold. And the distance metric I use is what's called the Jensen-Shannon distance metric, which is a modification of the well-known Kullback-Leibler divergence. And the modification is to make it symmetric and to make it a real distance. But detecting model drift is trickier because you don't have the output to know what the probability distribution is. So I had the intuition, hey, along with a prediction, you also get a confidence. How confident are you about that prediction? So if you analyze that confidence distribution, which is probability also, then you can compare the two, and it turns out it works very well. And we were awarded a US patent on it in 2019. So in many companies, what happens is either they don't monitor, or when they do, it's done manually. For example, we had worked with one of the largest retail chains in the US, and they rebuild their model at the beginning of every quarter. Now that made sense because the fashions change, the seasons change, their inventory change, usually at the beginning of every quarter. So that was fine. But then we worked with one of the largest banks in the US. They were using machine learning models for digital marketing. So they send out millions of emails and texts and so on, new products. But they want to identify those people who are most likely to click on their links. So that's where machine learning models come in. But they were rebuilding 3 times a week, which is amazingly frequent because it is an expensive process. The data is distributed in multiple silos, and it takes time to filter the data and build the data, et cetera. So when I looked at the data, their model, it turned out they were using 1 year's worth of data for building their models. And in that 1 year, a lot of change happened, and there was absolutely no need to use that much data. So my advice to them was to use only a 3-month window of data. And then continuously monitor. So the top shows the manual method. You manually rebuild, deploy, and after a certain amount of time, again manually rebuild and deploy and so on. But our method is to continuously monitor and automatically rebuild and deploy. So you're always tracking the changes and keeping your AI results up to date. Now I'm going to use several examples to show that this really works. So it's important to understand this data. You have 200,000 samples, and up to about 60,000, the data is well behaved, there's not much noise. But from 60,000 to 160,000 or 40,000, there is a lot of noise, and it becomes much worse in the last 60,000 samples. So here, what I'm going to do is again a prediction problem, a classification problem. The output is yes or no. So I divide it into 10 frames, each frame of 20,000 samples. So here it goes. The input actually consists of 25 different variables. What I showed was one particular variable, out of which only 6 were really important variables. The others didn't really matter. So a classification model was built to predict the outcome. And frame 0, which consists of the first 20,000 samples, was used as a training data. And we used that to predict the outcome of the next 9 frames. Okay. This shows the accuracy you get if you did that. So frame 0 didn't have much noise, so you are able to almost predictively, you have predicted very correctly, accuracy of almost 1. Same with frame 1 and frame 2. But frame 3 is when we first started to see a lot of variation and noise. And you can see the accuracy dropped to 80%. And that continues until frame 7, when there was even more noise, and you see the accuracy went down to 60%, and so on. So what happens? So this is what happens. This you don't know a priori. This only you can find out after the event has happened, and the outcome in the future. But the drift distance, so this is the drift distance that was calculated. For frame 0, it will be 0, because you're comparing against itself. For frame 1, it is 0.2, whereas the threshold set was 0.35, and so there is no drift. Similarly, for frame 2, again, it was low enough. But for frame 3, it shot up to 0.6. That means the drift is able to correctly predict what the accuracy drop is going to be. And therefore, you can raise an alarm, and you need to do a rebuild of, at the time frame 3 happens. Now, I put them side by side, so you can see the drift distance is a good indicator of accuracy degradation. Now, accuracy is not the only useful measure. For example, if you're predicting fraud in a bank, fraud happens rarely. Let's say 2% of the time there is fraud. So if my machine learning model always is no fraud, I'll get 98% accuracy. But that's not a good metric, because I need to how often are you saying there is fraud? And when you say it's a fraud, how often it is correct that was actually a fraud? So precision and recall are 2 important measures when the data set is skewed. And that's what it's showing. Here again, the precision, AU's, oh no, I didn't get to that. I'm sorry, let's skip this one. Yeah, this is what the precision recall, AUC. What AUC means, area under the curve, is another metric used in machine learning, because accuracy is dependent on the threshold you set. But what if you didn't choose the threshold correctly? You get around that by using area under the curve, where it is a plot of the false positive and false negatives. Okay, now we looked at the data drift is a good indicator of accuracy and precision recall degradation. What about the model drift? So I apologize. This output came from a program, programmatically generated output. And what you're seeing here is for frame 2, what is the distribution of the confidence values? So you have, most of them are concentrated around between 0.9 and 1.0, because there's not much noise in frame 2. It looks very much like frame 0. But what happens to frame 3? Now you see a dispersion. You see that, so here the distance is only 1.9, which is low. Here the distance is shot up to 99. So now this is a good indicator there's a model drift also. So what you do is now you have to rebuild. You rebuild the model, and this is what it looks like. The distribution of frame 3 looks like this. And how does frame 6 look? Frame 6 has similar data distribution as frame 3. Therefore, its distribution also looks very similar. But what about frame 7? That looks very different. And you can see the distance is very large, whereas here the distance is very low. Again, drift distance is a good indicator of model performance degradation. Now, again, you have to rebuild because frame 7 has exceeded the threshold. And this is the new confidence distribution. And frame 8 is very similar to frame 7, and you see it has a similar distribution. So the distance is very low, 4.9. And so the conclusion is drift distance is a very reliable indicator of performance degradation in machine learning models. They should be continuously monitored and rebuilt when there is actual drift. We have worked with a number of companies in the US, one of a major oil company, one of the largest banks, and bank for digital marketing, another large bank for credit card debt collections. You target those people who are most likely to repay the loan. And many insurance applications, auto and home insurance. So the software is all, well, the drift part of it is written in Python, the user interface in React.js, and the REST API and the server code in Java. So it's available for distribution now. Thank you very much.
Thank you, Doctor, for your enlightening speech. I will leave due to time, we'll leave all the questions for after the tea break. Our guest speakers, the 3 of them, will be available here. So if you have anything to ask them, please, you can ask them during the break. So thank you, Doctor.
Thank you.
Well, our following keynote speech is termed the National Program for Digital Economy, AI and Advanced Technology, Prospects. And it's by Dr. Nasser Mohammed Al-Fanna. I have the privilege of introducing Dr. Nasser with a brief video, please.
Let's introduce our distinguished keynote speaker, Dr. Nasser Mohammed Al-Fanna, Director of Technology Programs, Ministry of Transport, Communications and Information Technology, Sultanate of Oman. Dr. Nasser presently holds the role of Director of the Technology Programs Office at the Ministry of Transport, Communications and Information Technology, where he oversees the National Program for Digital Economy. Additionally, he serves as an assistant professor at the University of Technology and Applied Sciences and is actively engaged in research and review within the fields of cybersecurity and artificial intelligence. With 18 years of experience in information technology spanning across private, academic, and government sectors, he obtained his PhD in information security from Royal Holloway, University of London, and holds several professional certifications from reputable organizations such as Google, EC Council, and CompTIA. As we embark on this journey of exploration and discovery at Icat 2024, let us draw inspiration from Dr. Nasser Mohammed Al-Fanna's insights and vision for the future of technology. Please join me in extending a warm welcome to our esteemed keynote speaker.
السلام عليكم ورحمة الله وبركاته. بسم الله والحمد لله والصلاة والسلام على رسول الله. I cannot begin to explain how weird it feels to watch a video of myself being introduced to you. I guess maybe it needs some getting used to. As mentioned in the video, which saved me a few pieces of information that I don't need to share, I'm currently working with the Ministry of Transport and Communications and Information Technology, but I'm also an assistant professor at the University of Technology and Applied Sciences. And basically what that means that my 2 bosses are here sitting in front of me right now. Thank you very much, National University, for this wonderful conference. I wish it to be a fruitful and successful conference. I thank our honorable, esteemed guests who are here. I thank all of you also for being here. And I thank National University for inviting me to this. And sorry, I have to mention this. I thank Dr. Suresh also, who has suffered a lot trying to coordinate with me. I think he realized how it's difficult to get anything out of me or to send them anything. So I thank you very much for your patience. Okay, so just to skip to it, I'm not really here discussing any research papers, so depending on your interest, this could be good news or bad news. I'll just talk about how the situation here in Oman and globally in terms of digital economy and artificial intelligence. His Majesty, during his address in front of Oman's Council, has addressed two very important topics, especially for us. One of them is that digital economy is going to be one of the main pillars of our national economy. And it's very, very good to see such thing from our visionary leader. And this has been a push for us, in all aspects, to work even harder in this field. A good way of looking at Oman's situation is to look at some international rankings and international indexes. As you can see from the slide in front of you, we're doing quite well in some indexes, and we're doing okay in some indexes, but alhamdulillah, there is almost no index that we are not performing well in. As you can see in the ICT Development Index, we're ranked 33, which is a very good rank. In both AI Index and E-Government Index, we're ranked 50. In the Network Readiness Index, we're ranked 54, and our best ranking is in the cybersecurity field, which is 21st or 21 rank. Of course, these rankings are global, and this is where Oman is ranked or placed amongst other countries. Moving away from indexes, also looking at Oman's situation, currently the estimate of the contribution of digital economy in our GDP is around 2%. We have 10 Class A or Category 1 telecom companies. We have 5 data or cloud centers, and this number is definitely growing. We have 20 submarine cables, which is a very high number of submarine or internet cables that are connected to our country, and we're very lucky to have such thing, because many countries around the world don't have submarine cables because they're not located near the sea. And even the global average actually is just 5 cables per country, and we are well above that average, which gives us a very good position and a very good potential. In terms of mobile subscriptions, we are at 158%, which is again higher than the global average. The global average is around 112. So we have lots of people using mobile phones and technology in this country. This is our vision for the digital economy here in Oman. We're moving from what we can call as, or we can describe technology as being an enabler for the various sectors, all the way to reach to a stage where technology is not just an enabler for sectors, it's a sector on its own. It's where we manufacture things based on technology to begin with, where the end product is technology. So to have an industry revolving around technology, that is our ultimate aim. And as you can see from the chart or graph in front of you, we're gradually moving towards that objective. And as I mentioned in previous slide, the contribution of digital economy in GDP is 2%, and our aim is to reach 10% by 2040. However, I can tell you with some confidence, we are very optimistic that we'll not just reach this target, we'll actually exceed it by a good margin. We have something here called, in Oman, the National Program for Digital Economy. It was launched in 2021, and under the umbrella of this national program, we have 8 different programs that are covering various aspects or fields of the digital economy run. So we have a program for space, we have a program for artificial intelligence, we have a program for cybersecurity, we have a program for digital industry, we have a program for fintech, financial technologies, we have a program for e-commerce, we have a program for the digital infrastructure. And as you can see, these are various programs, and of course, maybe the program that most, that's why I left it for last, that most, especially ministries, are very familiar with, which is the program for digital transformation. I don't want to say one program is more important than the other, but they all have their purpose that they are trying to serve. And by the end of 2025, these programs will either be, some of them might be replaced by other programs, and some of them might continue for the upcoming years. I'm sorry, the clicker sometimes doesn't register the click, so. Okay, let's have a quick look. I know we don't have much time. A quick look at the artificial intelligence globally. Of course, in terms of what's going on, I'm sure lots of people are keeping up with ChatGPT. The world has gone crazy. Many changes. Now, if people were panicking before, now they've started panicking even more recently. But of course, there's the good side and the bad side. And definitely the bad side is every country in the world is now trying to manage that aspect. So it's good just to try to get the most benefit of it. Right now, AI is becoming the new scientist. So there are scientific discoveries that are being put in place or brought about by artificial intelligence. What is crazy is the other concept, where AI is developing AI. So AI is developing itself or working on itself. This is also a real thing that's going on now. So you find examples with Google, NVIDIA, where AI is developing its own self or improving itself. In terms of job automation, as you might know, this happened many times, especially, let's say, in the past 100 years, throughout the various industrial revolutions. Yes, jobs disappear, but again, there are other jobs that are being created and that take their place. In terms of investment, I always like to at least have one mention about investment for one reason. Of course, when it comes to AI, USA is the leading investor in AI. They're investing around $47 billion, which is exceeding even China in terms of investment. But what I like about saying or mentioning investment, we should all think about investment not just financially. We have to think about it as investing all sorts of resources, investing time, and there is, at this stage or at this point where we are in history, nothing better than to invest in AI. It's gonna, if it already started changing the world and it's gonna even change it even further, we need to all learn about it, whether we are specialized in this. Myself, I did my master's, my PhD in security. I've been teaching security, but for the past 2 years, I've been teaching myself or having even taken courses, and I even got involved in the AI research because I realized if I didn't understand AI, you know, the whole world is going to start changing, and I'm not really keeping up with what's going on. Just a quick slide about AI research. Currently, what happened between 2010 and 2020, okay, or sorry, 22, 12 years period, the research has doubled on AI, okay? However, the applications of AI doubled between 2017 and 2022. So the applications doubled in 5 years. However, the research only doubled in 12 years period. So that means research still has a long way to go to keep up with the changes and applications that are happening with AI. In Oman, in terms of AI research, I had to learn a new word today, which is research between 2017 and 2020. The research on AI here in Oman quintupled. I hope I'm pronouncing this word correctly. So, you know, there's double, triple, quadruple, and quintupled, which is the 5 times double the research number. But I have to say the number is still considered relatively low, but we're having big strides, which is a good thing, but we still hope for more research to be in this field. Again, I'm going back to His Majesty's address in front of Oman's Council. And also in this address, His Majesty talked about artificial intelligence and the launch of a national program for artificial intelligence. We have been working on this. The national program will see the light very soon. We're very excited about it. In the past, we had an executive program, which was a very small version of this, but now it has been amplified. It's much bigger, and I'll talk about some upcoming initiatives that are coming our way from this program. Okay, not much information here. I'll skip over it because we just have less than 2 minutes. Of course, there'll be some AI applications. We signed an agreement with the Ministry of Housing. There will be AI applications in the upcoming His Majesty Sultan Haytham's city. I'll tell you about some projects. We have drone deliveries in Oman, which currently covers Muscat Bay area only. And hopefully, in the future, it will expand to other areas. We have very distinct success that has been recognized globally, which is the e-elections. And we're very proud of this success. You can see there's an article by the Washington Times that is specifically talking about our procedure for the elections and how it's completely electronic. And the author of this, or the editor of this article, has recommended to the US government to follow similar steps to what Oman has done in terms of elections. So something to be very proud of. Also in terms of AI, we have currently a program with the University of Technology and Applied Sciences. And it's covering various aspects. And inshallah, we're looking forward, or the minister is looking forward to expanding such cooperations with other universities as well. Just this final slide.
Go ahead, Doctor. You have still a good 3 minutes and 2 seconds.
Okay. I mean, I had the timer at 15 minutes, and it says 10 seconds left. So I don't know about your timing. I just need the colored slide. That's my almost final slide, sir.
We can flip the...
No, that's fine.
Yeah, cool.
Okay, just some... see, my watch is vibrating. 15 minutes done. Some upcoming projects. We're working on Oman's national LLM, large language model, which is Oman's version of ChatGPT. And we're also going to launch this year, inshallah, the World Economic Forum 4th Industrial Revolution Center here in Oman. We're working very hard in terms of laws and regulations. We're trying to keep up with the technologies and the changes that are happening with them. And also we have an initiative in the realm of quantum computing. Of course, quantum computing is still a developing technology. We're not saying that we're developing a quantum computer anytime soon here in Oman, but we're starting towards this technology, and we're working on it. And inshallah, we'll see some achievements in the near future. This QR code, if you were interested, all the information about the National Program for Digital Economy can be found on the ministry's website. You can scan this QR code. Of course, you can also follow up with the ministry's news throughout various social media accounts. I thank you very much for your attention, and I hope you enjoy the rest of your day.
Thank you. Thank you, Dr. Nasser, for taking us through the National Initiative for the Digital Economy. Barakallah fiqh. Allow me to introduce Professor Sayyid Ali Mir Jalili, our next distinguished keynote speaker for today, with a brief presentation of his profile, who is renowned for his groundbreaking work in AI. The title of his talk would be Navigating the Maze overcoming difficulties and optimization for challenging real-world problems. Dear Professor.
Introducing Professor Sayyidali Mirjalili, a luminary in the field of artificial intelligence, whose groundbreaking contributions have reshaped our understanding of optimization and swarm intelligence. With a career spanning decades, Professor Mirjalili stands as a beacon of innovation, pushing the boundaries of AI research and inspiring countless scholars worldwide. In 2019, Professor Mirjalili founded the Center for Artificial Intelligence Research and Optimization, a hub dedicated to unraveling AI complexities. Currently, he holds the position of Professor of Artificial Intelligence at Torrens University, Australia, where his passion for discovery fuels groundbreaking research. His impact extends globally with over 500 publications, 80,000 citations, and an impressive H-index of 95. Recognized as the most cited researcher in robust optimization, he ranks among the top 1% highly cited researchers worldwide. In 2020, he ranked 21st across all disciplines and 4th in artificial intelligence and image processing in Stanford University's list of world's top scientists. The Australian newspaper named him the top researcher in Australia across 3 vital AI domains in 2021. Please join me in welcoming Professor Ali Mirjalili, a true luminary whose contributions will continue to resonate for years to come.
Well, thank you very much. Good morning, everyone, and a warm welcome to all of you. I'd like to first start with thanking the conference organization team and the NU University for the great invitation. It's my pleasure to be here. And more importantly, it's great to be a part of the first, session of this conference, and also the first year of the conference. I believe that when you build something from scratch, you can lay the foundation very strong, and we are here to lay a very strong foundation. Hopefully, we can keep the momentum for the future as well. My name is Ali, as Dr. Suresh introduced me in the video, and I'm a professor of AI at the Torrens University of Australia. It's like NU University. It's the biggest and the fastest growing private institution, university, I should say, in Australia. And when I joined that university a few years ago, I was asked to fund a research center, and that's where I come from, the Center for Artificial Intelligence Research and Optimization, which is exactly what I'm going to talk about today. You heard about the optimization already. The Vice Chancellor addressed us on the application of AI in engineering, which is mainly around optimization. You heard about optimization already in the previous talks as well, gradient-based algorithm and stuff like that. I'm here to take you through a bit of a journey. I'll take you through, I'll take you through a story and show you how I see the field of optimization through a lens of a problem. But I believe that all of us come from a background and we have our own story. And I always share this story with people, and hopefully that will resonate with young academics and early career researchers. The reason why I'm still doing research goes back to when I was 10 years old. I was, a young kid going outside, always exploring nature. We had a backyard. I always chased butterflies and, put ants on fires, chase them. It's just always amazing for me to, look at the nature. But one day my father came back home with a computer. It was a Pentium 3, and he was doing his PhD. So he used to do programming a lot. And it was amazing for me. I asked him to teach me, and he did. And at some stage, the idea came to mind. So instead of going and, chasing butterflies, why can't I mimic them in the computer? Can I create an algorithm of some sort? And that's exactly the same drivers this day for me and my research team. So we design nature-inspired algorithms. So today I will show you, towards the end of this talk, I will share my view and why, and explain why I think nature is the best source of inspiration when it comes to optimization. So this is the outline of talk. I'll be quick, short, and sharp because we have a tea break coming up. I'll take you through some challenges that we face and engineers face. We've got a lot of engineers in this room. So you see what are the common challenges people face when it comes to optimization. I'll take you through the most fundamental components of optimization algorithm, and then I'll move on to optimization problems, and then I'll move on to optimization algorithms. And the reason why I start with the problem is because without a problem, an optimization algorithm is useless, right? An analogy is lock and key. The key by itself doesn't do anything. It's the lock that gives meaning to the key, right? So that's exactly why I tend to encourage people to first focus on the problem rather than just going and chasing to find the best algorithm out there. So first part, optimization problem. Whether you are optimizing something at the nanoscale or at the macro scale, they have the same foundation. And I'm not going to call it optimization problem. It can be a system. It can be a business process. They have the same foundations, the same fundamental components. We have a set of inputs. Those are the unknowns, variables, whatever you call them. These are the parameters that we have to find the best optimal values for. We have an objective, or it's an output of the system. We are trying to minimize or maximize it. I don't know, cost functions, whatever you call it, there are different terms. Performance, efficiency. But also we have a set of constraints that limit the system. Those are the constraints. Those constraints will allow us to decide whether a solution is viable or not. And that's a very fundamental step in solving any optimization problem. When people approach us, whether in the science, from the academy or industry, the first thing I ask them is to grab a piece of paper and draw a table and list down those three components. And it all starts from here. And after that, what happens, we go and obviously formulate a problem, right? So here's an example. We are trying to minimize the cost function, which is a function of all the inputs subject to not violating those constraints, right? And that's where an optimization algorithm comes in. The idea is to find the best values for those inputs to maximize or minimize output while satisfying those constraints. And I'm a very visual person. You'll probably see throughout this presentation, I have a lot of visualizations just to make it more engaging and easier to understand. So all I'm trying to show you now is that whether you have 2 variables or 2,000 variables, or these days the ChatGPT deep learning models, billions of variables, well, what you're trying to do at the end of the day is you are trying to navigating, and that's the title of this presentation, Navigating the Maze. You are trying to navigate that maze. You see the search space on the right-hand side. You've got 2 variables, x and y axis, and the z-axis is the objective function. You can extend that to n-dimensional problems. So the optimization algorithm is responsible to find, those, peaks and valleys, probably the minimum, the best one, while avoiding all those constraints. So how do we work with people? Well, obviously there's a bit of workflow here, right? So I'm going to go back to this slide. So it all starts with, I don't know, there's an auto movement. Anyway, so we all start with the discussion between us and what I'd like to call problem owners. It could be an industry person, somebody in academia, anyone who owns a problem. Then what happens with that, we sit with them and formulate the problem. Often as optimization expert, we are the one who help them to better formulate the problem. Then we go away with the problem, we try to optimize it and go back with the solution. After the quality check of the solution, we may get the green light or not, or get our final check or not. But in my experience, it's an iterative process. You go through this iterative process. There's no other way to do this because of the complexity of the problems these days. And after that, obviously, when we get the green light, then when the solution is optimal enough from the point of decision makers, that's the end of the process. So one thing I want to emphasize is that it should be an iterative process because of the complexity of the problems. The other one is that what we realize over the years is that one of the most common mistakes that most engineers do is to optimize something that is absolutely unnecessary, or something that can be simplified. And I'm now talking probably, against myself and my area, saying because we love complexity, right? We want to, find best solutions, but that's not true. To me, simplification should be favored over optimization. And a good example is what SpaceX team is doing. Instead of them sitting down and optimizing the engine on the left-hand side, which is the version 1 of Merlin engine, they started to simplify. They believe in to cut back, simplify it until you reach the baseline, and then build from there. So all I'm trying to say is that what the first key message I want to deliver now and want everyone to remember is always think how you can simplify the problem before finding an algorithm, before even optimizing it, right? That's a key step. And as I said, the success of some of the large companies under that sort of leadership is from that simple process, that simple mindset. Obviously, engineers face a lot of problems when trying to formulate their problems. When it comes to variables, you have a mix of continuous and discrete, which is what we call mixed integer problems. We might have noises during manufacturing, so you find an optimal design and you give it to manufacturer. They have some sort of uncertainties, so you don't get the performance you needed. So if these are the sort of challenges you deal with as an engineer, there are niche areas in the optimization community. For example, we have combinatorial optimization community. We have robust optimization community. So you should be able to find and narrow down and find ways to address those challenges. When it comes to constraints, again, a lot of real-world problems deal with a lot of constraints. And when you have a large number of constraints, you don't know where to start because every solution you come up with is already infeasible. You have sometimes equality constraints and non-equality constraints. Those are the sort of challenges people deal with. And again, if you identify them properly, if you spend 1 week on this or a few weeks on this, it will pay off because you need to be aware of those challenges. And we can help you as as optimization expert. And that's what my team does with industry expert and academics across the globe. Objectives, most real-world problems have multiple objectives. Now you're trying to deal with multiple search spaces. Those search spaces sometimes move. They are dynamic, like, safe-driving cars is a good example of that. The search space changes in a few seconds. So you should be able to track those optimal solutions as well. So those are the sort of areas that we do research, multi-objective optimization, dynamic optimization, just to make sure that we have enough algorithms and techniques to cater the needs across the engineering sectors and other sectors as well, because optimization techniques, problems are everywhere. And I think it's a good time to do a classification. That's what we do with people when we try to narrow down, the problem into these areas. We can categorize them based on the formulation. We can categorize them based on the type of the search space that they deal with. And after we put pins on these boxes, that's where we can start the optimization process. And I think that's a time to say, welcome to our world. This is how we see worlds. Everything around us can be seen as an optimization problem. Even putting this agenda together, this conference agenda, the plan, right, the timetabling, these are all optimization problems that we deal with on day-to-day basis, right? So, and those are some of the case studies that we've been working with people, as you can see, from construction management to structures to timetabling, and I believe that the demand for optimization algorithm will be there forever, right? Unless we come up with AGI, artificial general intelligence, in which the algorithm will be developed automatically, which I will address towards the end. And that was the first part of my talk. Now that we know how important optimization problems are, and it should be, and the fact that simplification should be favored over optimization, let's talk about algorithms, right? You heard in the first keynote speech that people used to use a lot of, they're still using a lot of gradient-based algorithm. So if you can calculate the derivative of your search space or your problem, it will lead you to an optimal. That optimal may or may not be a good optimal. Obviously, the ideal goal is to find a global optimum, but it may not be. But it is still a relevant algorithm. That's the second point I want to make. A lot of people make a mistake to try to find a fancy algorithm for the problem. But if this solves your problem, it's still quite relevant algorithm. It's the foundation of deep learning community. Still all the neural network, the deep learning techniques that we still use these days are optimized using some sort of gradient-based algorithm. So the deep learning community is pushing that sort of agenda and a gradient-based algorithm simply because their problem can be, you can calculate the derivative of the objective function, which is the noise or the mean square error of the neural network. And there's a lot of improvement here over the years. The idea is to address two issues. One, to avoid locally optimal solution. Second, not to converge too quickly. So as you can see, some of the algorithms tend to wander around to avoid local solution, but at the end of the day, they all converge to the same space in this problem. And some of them are able to address the saddle point in which you get gradient in a different direction, but some of them still get stuck in here, right? But the question is, can we easily use these kind of techniques in engineering problems? The answer is no. Why? Because most of the time when we have an engineering case study, you cannot calculate the derivative of the search space, right? Or it's too difficult, or you need to approximate, or you need to estimate it, which makes it less accurate. And that's exactly where this area, the area that we do research, and that's exactly where AI comes to the mix. So we are saying that instead of using gradient-based algorithm, why don't we use stochastic algorithm? Instead of doing a search locally, why don't we make it globally and go through all the corners of a search space? If instead of being deterministic, why don't we let the algorithm to decide whether it reached a solution, a proper solution or not? And instead of using a single solution, why don't we use a population of the solution? So as I said, AI is a big umbrella, and that's exactly where we develop algorithm looking into nature. So if you look at that, AI is a big umbrella. We've got all these branches, but that's where we are. That's exactly what I'm talking about. The algorithm that I'm about to show you sit in this category. Computational intelligence, that's soft computing, evolutionary computation, evolutionary algorithm, and swarm intelligence. Most of the algorithms that we develop over the years are in this category. So, you're right, the clicker doesn't work sometimes. Yeah, a lot of people...
you have 3 minutes.
Yeah, I'm about to finish. So a lot of people criticize this algorithm being not deterministic, which means you don't always find the best solution, which is true. And that's because of the compromise that you have to make. You need to make that compromise because you can't go through all the possible solution for a problem. So you need to search a portion of the search space. So you can use quality assurance techniques to make sure that your solution is optimal. So before I wrap up, a question that a lot of people ask us is why a lot of research algorithms are nature inspired? To convince you that it's a good way to approach problems, I need to refer you to a theorem called emergent complexity. This theorem says it refers to a phenomenon whereby large entities arise through interaction among smaller or simpler entities. You can think about a system with small entities. It could be particles, it could be ants, it could be birds, and some sort of rules to bring them together and allow them to cooperate. Cooperation is probably a loose term here because it could be particles, interacting with gravity, right? But at the end of the day, they get together, they interact, and reach some sort of stability. Or in other words, what we get is some complex behaviors resulting from optimization process. And nature is full of these examples. Like those crystals in snowflakes are a result of emergent complexity. Water molecules, when they fall from the sky, they go through an optimization process and they create these kind of nice crystals. Sand domes in deserts, right? Those particles, sand grains, and all the forces, gravity, wind, other forces, they will reach to this stable. So that's an optimization process. And nature is full of these examples, right? You see birds, what you see up there, a swarm of birds trying to minimize energy consumption in a very complex environment. We've got, school of fish, wolves, ants, and thousands of other examples, right? So all I'm trying to say is that emergent complexity is the foundation of this area. It's not always good, obviously. You can create complexity artificially. But all I'm trying to say is that complexity, when it comes to nature, might be for a good reason. And that reason is optimization. So if you say an ant colony, for example, it's a complex behavior, right? And that's because it's probably the best solution for the problem that ants been dealing with, like finding an optimal path from a nest to a food source. So it's good. So it's wise for us to inspire from them because a lot of problems in computer science and engineering are quite similar to the ones in nature, like path planning, timetabling. So instead of we going out and developing something from scratch, we can inspire from nature. And a lot of, and don't take my word for this, these are some codes that show how important it is to look into nature. I've got 1 minute more. A lot of examples, obviously, but this is an example of an algorithm based on a flock of birds. So we try to find mimic the interaction between them, and instead of and we deploy those artificial birds on a search space, and they will be able to find an optimal solution. What you see is what we optimize is a ship propeller as big as even taller than a human. And as you can see, those birds will converge to a point, and we managed to improve the efficiency by 6%, I think. And a lot of other examples. I don't have time to go through them. If you're interested, trying to go to the next slide if you can help me. Ant colony optimization, grave optimization, all the algorithms out there, a lot of algorithms out there are based on the same principle. So you develop those artificial entities, you deploy them on a search space, and they will be able to find a reasonably good solution for your problem. But where we are heading, that's a key point for the future. If you look at the history, we started with some niche algorithm, like gradient-based algorithm for one problem. Then we moved on to meta-heuristic, a wider range of problems. Hyper-heuristic, the algorithm that they can tune themselves. If we follow the same trajectory, we increase automation and less human involvement. So those are the open research questions now for young researchers. How do we automate the algorithm development? How do we even automate the problem formulation, right? And at the end of the day, how do we reduce human involvement? To me, generative AI will play a key role. We will have a lot of generative AI-based algorithm, so which means that the algorithm will be developed or rebuilt during the optimization process, which will basically take out the human involvement from the optimization and keep that sort of oversighting and quality assurance. And that's all I've got for you. These are some takeaways, obviously. If you find these kind of stuffs interesting, that's my website and email. You can find, a lot of resources, book chapters, online courses. And feel free to reach out. We'll be around, as the chair said, and I've got a contact form. Feel free to reach out if you have any question. Thanks, everyone, and
thank you.
Enjoy the rest of the conference.
Thank you, Prof. Thank you for Said Ali for truly inspiring us. And I'm getting a lot of messages as questions, as if like I'm getting like an FM request over here. So after the break, please join if you would like to ask any questions for our three speakers. And I would like to have a very warm applause to our three speakers who have shared us with their knowledge. Fatma, please.
Thank you, Dr. Talal. On behalf of the Icat 2024 Organizing Committee, may I now request Dr. P. Muhammad Ali, our Honorable Pro-Chancellor, Dr. Ali Al-Bimani, Vice Chancellor, and Dr. Salim Al-Araimi, Deputy Vice Chancellor and Provost, to join us on stage and present mementos to our keynote speakers. As a token of appreciation, may I request Dr. K. Mohiuddin to receive a memento. We would like to present a memento to Dr. Nasser Mohammed Al-Fanna. I request Prof. I request Prof. Sayyid Ali Mir Jalili to come on stage to receive a memento. Your Excellency Dr. Ali bin Amr al-Shaydani, Chief Guest and Patron of our conference, your presence at our event added a distinct honor and prestige that elevated the entire experience for our attendees. We'd like to give you a memento. Thank you, Your Excellencies. Your Excellencies, distinguished guests, invitees, speakers, and authors, thank you for attending this inaugural function. We wish all participants successful deliberation during the coming sessions. Dear delegates and keynote speakers of the conference and organizer, before we meet again for the technical sessions at 11:15 a.m., after the tea break, please join us for a group photo session near the pool area at 11:10 a.m. Thank you all.